Hello everyone. Tonight we're going to be working on objective number 95, problem 5. In this equation, or in this problem, we have about 6 different steps that we're going to work through, and we are asked to consider two functions, f and g, on the intervals 1, 7, such that, and we have 4 integral functions, 2 with f and 2 with g. Our first one is with the integrals 1 to 7, that's here, f of x with respect to x equals 15. The integrals 1 to 7, g of x with respect to x equals 6. The integrals 6 to 7, f of x with respect to x equals 7. And then the last one is with integrals 1 to 6, g of x with respect to x equals 4. And that was a little tight on that side. Sorry about that, but that is a 4. And we're asked to evaluate the following intervals. Okay, so for A. In A, we are asked, we're given the intervals 1 to 6. We also have a constant of 4 in our function. So it's the integrals 1 to 6, 4 f of x equals, with respect to x equals 4. Actually, this is all we're supposed to be finding right here. Let me back up. The integrals are 1 to 6, 4 f of x with respect to x. That's what we're trying to find. Well, if we'll look back up here, we don't have one that has the integrals 1 to 4 with our f of x. So we have to find, 1 to 6 f of x. We have 1 to 7 and 6 to 7. So the first thing I'm going to do, and I've already written this down to save time, is pull out that constant. Pull it to the front. So now we have the constant 4 in front and the function with integrals 1 to 6 f of x with respect to x. Now, in order to find the integrals 1 to 6, we've got to do a little math, and we're going to take what we know. We know 1 to 7, the function 1 to 7, and I've written that down. That is 15. So, we're going to take that 15, and we're going to write it down, and we're going to put our subtraction sign, because in order for us to do this, see, we have 1 to 7 here, and we have 6 to 7. We know the function of x from 6 to 7 integral and from 1 to 7 integral. If we subtract this integral from this integral function, then we're going to be able to find out what 1 to 6 is. So we know that the integrals 1 to 7 is 15, and the integrals 6 to 7 is 7. So now we have 15 minus 7, and 15 minus 7 is 8. So the integral function 1 to 6 f of x with respect to x is 8. Okay, and we need to remember that because we're going to use it again here in just a little bit. So let's don't forget that one. Okay, B is fairly easy. It's pretty straightforward. Everything is given to us. We are looking for the function, or we need to evaluate the function with integrals 1 to 7 f of x with respect to x. And the online homework doesn't write all of this out, but Ms. Crouch did teach us to do that. So I did write all of this out. It just helps us keep everything straight. We are looking at the functions with the same integrals 1 to 7. And be sure and put that dx in there because that's important. So I'll put it in both functions of this equation. So the function with integrals 1 to 7 f of x with respect to x is 15, and the same integrals 1 to 7 function g of x with respect to x is 6. So we have 15 minus 6, and 15 minus 6 is 9. And so the answer to B is 9. Okay, I'm going to move this down like this so that we can keep these functions that we have to look at because we may need them. Okay, here's where in C is where I told you that you would use your answer for the function with integrals 1 to 6, f of x with respect to x equals 8 from a. This is what we found in a. And we're going to use it this time because this time we are asked to find that function with integrals 1 to 6, f of x with respect to x. And we are to subtract it from the same function of g of x. So we know the function g of x with the integrals 1 to 6, and that is 4. And we found f of x, which is 8. So 8 minus 4 is 4. So C is 4. Okay. Now for D. D's a little bit tricky. In D, we are asked to evaluate the function g of x with respect to x with integrals from 6 to 7. And we're also asked to look for the same function f of x. Well, we're given that one up here. The function with integrals 6 to 7, f of x with respect to x is 7. So we know that one. We do not know this g of x function. What we do know is that the function with integrals 1 to 7 is 6, and the function g of x with integrals 1 to 6, g of x is 4. So we're going to use that. And I did this a little bit differently than the way that it's explained on my math lab. It was easier for me. I'm going to show it to you guys, and hopefully it'll be okay with you. The problem works out the same way. For me, it's just a little less confusing. This is the way I did it. The first part that we have to, this is the part we have to find. We have to find this function. So the way I did that was I went ahead and wrote down what I knew, and I know with integrals 1 to 7, g of x with respect to x, and I also know with the integrals 1 to 6, g of x with respect to x. I'm given those. And I know that I'm looking for just the integral between 6 and 7, or from 6 to 7. Well, I know 1 to 7, and I know 1 to 6. So I can find 6 to 7 by subtracting. So I'm going to do that. Well, I need to do that first before I evaluate any other functions that I'm asked to evaluate. So I'm going to put those in parentheses. I know that I've got to find the function g of x with integrals 6 to 7 first. Then I'm going to go ahead and add the rest of my equation here, what I'm looking for, and that is with integrals 6 to 7, f of x with respect to x. And I've already, as I said before, we already know that one. It's given to us. Okay, so let's fill in our numbers. G of x with integrals 1 to 7 is 6. We know we have to subtract it, and g of x with integrals 1 to 6 is 4. And remember, we're doing that first, and then of course f of x from integrals 6 to 7 is 7. Okay, so 6 minus 4 is 2, and 2 minus 7, and we can put equal signs here, and 2 minus 7 is negative 5. So our answer for D is negative 5. Okay, that one was a little bit harder, but I thought that doing it that way made it a little less difficult. Okay, it should be F. Okay, let's look at E. The first thing is that we're looking for integrals from 6 to 7. We're looking at the function g of x with respect to x, and we don't have it given to us up here, but we did find it in D. If you will remember, that's where we subtracted those other two, and I told you to put them in parentheses because we did need to find that number. So we did find the function g of x with respect to x at the integrals 6 to 7, and that is 2. We found that in D. So we know that this portion of what we're evaluating is 2. Okay, and as you can tell here, I went ahead and pulled out the constant. We have a constant of 9 in this function, pulled it out to the front. So this portion of our function is 2. Bring down that constant, and we're going to multiply that. So now we have 2 times 9, which equals 18. So our answer for the function from integral 6 to 7, 9g of x with respect to x is 18. That's E. Okay, and one more. This is what we're asked to find. And I'm going to put my hand right here for just a second. We're asked to find the function with integrals 6 to 1, 6 f of x with respect to x. Well, we have a constant here, so let's go ahead and pull that constant out because we know we can. It is a constant, so we can pull it to the front. So I went ahead and did that, kept the same function, not doing anything different here. Now, if we go back to what we were given, the functions we were given, we were not given the function with the integrals 6 to 1. We have 1 to 6 for g, and we found 1 to 6 in A, which is 8. We found 1 to 6 in 8, but we're not given 1 to 6. Well, if we know our properties and our rules, we know that the function with integrals 6 to 1, f of x with respect to x is the same or equal to the negative of the integral's opposite. And we do know the integral's opposite. The opposite would be integrals 1 to 6 instead of 6 to 1. So the opposite or the negative of the function with integrals 6 to 1 is, it's the negative of 1 to 6. Hope I didn't confuse you. So we do know that the function with integrals 1 to 6, f of x with respect to x is 8, and we are going to take the negative of this. Well, let's don't forget that we have a constant up here. So we have a constant of 6. We've taken the negative of this function that we're looking for, and we know that now we have, if we bring down this constant and put it into our opposite or our negative of, then we know that our original function is also equal to the negative 6 integrals 1 to 6 f of x with respect to x. Therefore, we can just plug in what we know now. And this is what we're looking for now. We've pulled out the we've got the negative because we're doing the opposite, or we're doing the negative of. We brought down our constant that we've already pulled out. The only thing we have left to do is plug this in. So let's bring that negative 6 down and plug in what we know for this function, which is 8. So now we know that, let's put it down here. Okay, we know that the function, integrals 6 to 1, f of x with respect to x is equal to negative 48. Negative 6 times 8 is 48, and that is F, and that completes problem number 5, objective 95.